Hello everyone and welcome to this new tutorial in the PyTorch 101 series, and today I'm going to show you how you can take the first steps towards training a first neural network model using PyTorch. So the first thing that we always do in machine learning, deep learning lectures is to train our own linear regression model. So that's what we are going to do today. And I'm going to show you how you can do this using PyTorch, and it depends on what we have already learned in previous videos. So in future videos and even in this one, I will be reusing a lot of things that I've already shown you in the previous videos. So if you have missed something in the series, it's going to be difficult for you to understand. So I would recommend you to go back and take a look at the other videos in this series before watching this one. So let's create a new notebook since we are playing with notebooks. So this one will be the 7th lecture, let's say. And in this one, we are going to be training a linear regression. Okay, so some things that we have already done, and I'm going to keep these lessons very short. Some things that we have already done is to create a custom class. So I'm just going to take this one and let's put it here. Let's also import some of the things. So we have imported torch, we have imported make classification from sklearn datasets, and this custom dataset that we created in the third video of the series. So now what we are going to do is we are just going to create a dataset. Let's say I create a dataset with data and targets, and just use make classification from sklearn. And here we can just specify the number of samples, and everything else remains the same as before, same as default. So you don't have to worry about it. It's a simple binary classification problem. And now what I'm going to do is let's also import from sklearn dot model selection, import train test split. Okay, so we have the train test split, and here I'm going to do like train data, comma, test data, comma, train targets, comma, test targets. So this equals train test split, and here we can specify data, targets, and we have stratify. So whenever you have a classification problem, just do a stratify on targets. It keeps the ratio of the number of positive to negative samples same in all folds, but here we have only like two folds. So one is the train, and then you have the validation. So okay, train test split is not defined. So okay, let's run this again, and here you go, everything is fine. So the next step would be to just load this data. So train dataset will be custom dataset, and here you input what are the inputs to the data. So data and targets, and data here will be train data, and targets will be train underscore targets. Okay, I'm sorry about that. And now we can just take this, and you have test dataset. So train and test, or validation, whatever you want to call it. Let's call it test because I wrote test here, but that's the dataset we are going to be validating on. And now we got the train dataset, we got the test dataset, and we also need the train data loader and test data loader. So this is also we have seen in the previous lesson, let's say. So we have the train loader and the validation loader, and we are just going to use that. So we are going to say train loader, torch utils data loader dataset. Okay, so this will be train dataset, and similarly you have test loader, which is the test dataset. So far so good. So now we create a function like y equal to mx plus c, like you have studied in high school. So I would say that this is my model, and model is lambda x, w, and b, x weight and bias, and this is torch dot mathmul. So we have studied this in the tensors lecture, x comma w plus b. So this is nothing but just a function. So given x, w, and b, return this. That's it, and that's your model. So we have the model now, and let's take a look at the train dataset. So train dataset dot shape. Train underscore data shape. So we have 20 features and 750 samples, and 250 are for validation. So you will see a lot of people will also do w.transpose. So it's all about the dimensionality of w as you choose. So what we are going to do is we are going to choose initialize w. So torch dot random, as you have seen in the previous one, and requires grad equal to true. So if you do 1,20 here, then you have to do the transpose thing. So it's as simple as that. And then you have w, and you have b, and b will be 1, shape 1, torch dot rand n 1 comma. So this is the number of features that you have, 20, and you have one output. That's it. Nothing very complicated here. It's a binary classification problem, but instead of 2 outputs, we are just using 1 output. That's it. Requires grad equal to true. And choose a learning rate. Learning rate 0.0.001, let's say, the most common learning rate. And now we do the iterations, the epochs. So for epoch in range 100, let's say we want to run it for 10 epochs. 100 would be too much to start with. And epoch loss is 0, so something in the loss. And in each epoch you are going around the whole data set that you have. So you will say for data in train loader, and this is going to give you the data set, and it's going to give you some training data set. So what do we have here? X and Y. This is what you're going to get. So data X, and your Y is data Y. So far so good. And now what you do is you will calculate the output. So output will be equal to model, and this takes X comma Y comma W. Okay, right. And once you have the output, you calculate a loss. So let's say loss is mean squared error. So loss is, let's say, torch dot mean y train dot view. So I'm just saying, okay, do -1 minus output dot view -1, and take it inside one more bracket like this, and square. Okay, so we are calculating the mean, and we are saying, okay, this is y train and output, so it can be output minus y train if you want. or anything. And epoch loss is epoch underscore loss plus loss dot item. So this will give me the value of loss. So now we have done all this, and we need to calculate the gradients now. And to calculate the gradients, as we studied in the previous ones, we just do loss dot backward. So now we have calculated the gradients. So we have the gradients for W, and we have the gradient for B, but we don't have for X and Y. So now once we have the gradient for weight and bias, we need to update the weight and bias. So these are the basic things that you have already seen. So what you do is you use a context manager and say with torch.noGrad without so what torch.noGrad does is, it's in this context it will just temporarily disable requires grad. So now requires grad will become false whatever you write inside it. So I will write, okay, W is equal to W minus learning rate multiplied by your W dot grad. Okay, and similarly you also update B dot grad. Okay, so once you have done this, you just set W dot requires grad underscore, and when you do underscore in most of the functions with tensors, when you do underscore, it's in place. So you don't have to do W equal to W dot requires grad equal and true. You can just do with the underscore true and B. So you have calculated the gradients, you have updated your weight and bias, and then you say, okay, now in the next iteration do requires grad equal to true again. So refresh it kind of. So let's run it, and it gives me an error that X is not defined. Okay, so it should be X train and Y train. Okay, so I do get an error again, size mismatch. So now we see here 20 cross 4, 4 cross 20 comma 4. That's actually, I think, okay, here, okay, it should be, okay, so this is wrong. It should be this one. So X and W and B. So anyways, no harm done. So we start again and we come here, and now everything runs fine. So okay, this also runs, but we don't see anything. So let's try to see some stuff. So what I'm going to do is I'm going to print epoch and epoch underscore loss. So we have updated the epoch loss here. Okay, and we in every iteration we initialize it from 0. So let's print this. Okay, so the loss is reducing, so it is learning something. So one more thing that you can do here is, here you can have some kind of counter, set the counter to 0, and for each new item that you're getting, you can increase the counter by 1. So here you can say counter plus equal to 1, and when you print the loss, just do divide by counter, so you get actual loss. So let's try to run all this again. Okay, so now this looks much better, and much lower losses. So this is iteration 0, iteration 1, and you have the corresponding loss. So one more thing that you should know or remember here is you have to 0 grad the W and B, but Torch is doing it for you automatically. So let's try to print something here. Print W.grad. So in the very beginning, we print W.grad, and let's see what happens. So it's none. And if we do if we do it here, print w.grad, we should get some value. So we do get a value. So once we do an operation with it, it disappears on its own. Otherwise, what you can do is, so let's write it here, and let's write it here, and just let's run it for one iteration. Okay, so it was none. It started from none, then you have some value for the gradient, and then it's none again. So once you have done the operation with it, it just disappears. But if it doesn't, what you can do is you can write if w.grad is not none, w.grad underscore 0 underscore, and it will make the gradient 0 or none. Okay, so now we have trained our model, and it's always a good practice to verify that model. Here it was a very simple linear regression. So let me remove all these breakpoints and run everything again. So it is training, and now what I'm going to do is, since it's a binary classification problem and also skewed data, I will calculate a metric on the test set called AUC, or area under the rock curve. So we have outputs and we have labels, and I will just do what with torch.noGrad, because we don't need any grads anymore. And for data in test data loader or test loader, go through all samples. So I will just copy paste this one and also this one. So here we have X train, Y train, and output, and we already have updated W and B due to this loop. So it doesn't start from random anymore. We have it updated now. So if you do like here, you can print the value of W and B. So these are updated values. And so we got the output, and then we do labels dot append. So your labels are just Y test. Let's call it Y test instead, and X test. Okay, and your outputs are outputs.append output. Let's keep it like this. So we got some things in outputs. So we got a list of tensors. So now what I can do is I can just do view -1. No, so I will just do torch.cat. So it's just going to concatenate everything, and then view -1. So now I got a simple tensor, and I'm going to do the same thing with labels. Torch.cat output labels, and when I have that, so I got these two values, I can just do metrics dot, so let me import metrics from sklearn, import metrics. I can just do metrics dot ROC AUC score, and here I got my AUC score, which is 0.91. so pretty good model in the end. And you can also like test it something like this. So you have the W and B, and let's try. So I've removed the lines here, the training lines, and what I'm going to do is I'm going to put them here, and I'm going to copy the test part and add it here. So my test part is here, and I will also calculate the metric. So let's try to run again. So we have all the imports, we have the custom data set, we create the data set, classification data set, we split it, we need the custom data set class, then we have the data loaders for train and test, then we have the model, we check the shape of the data, okay fine, we need W and B, and then we just use the W and B, the random W and B, to calculate the outputs using the test data. And then we calculate the ROC AUC score, and this gives me 0.28, which is quite bad. So then what I do is I train the model or learn the values of W and B, and then I use those values and then calculate the metric again, and it gives me 0.929. So yeah, it is working. You created your first linear regression kind of model, and not kind of, but linear regression model, and it works, and you used Torch. So now in the next one, we are going to take a deeper look at the training loop, and then in future we will go to some complicated models. But please note that I'm going to be reusing what I have already discussed, so if you miss some video, it's going to be difficult for you to understand, so let's not do that. And if you like the video, do click on the like button, do subscribe, do tell your friends about it, and see you in the next one. Bye.